glad that you showed up today, because it was a really nice day out, and I was like, oh man, this could be dicey. I thought for sure everyone was going to be out the last minute. Also, there's like another conference that's going on in town, so I thought for sure people might be busy with that. So thank you all for coming. I just want to start off our night by saying thanks to our sponsors, North Sail Software and Microsoft. Both are our full season sponsor, which enables us to, hey, you guys just made it. There's North Sail Software in the house. Yes, Don and Natalie. So big kudos to them and to Microsoft. Without them, we wouldn't have funds to pay for the room or food or drinks or things like that. So big round of kudos to them. And our committee. So I'm Lori Lalonde, for those of you that don't know who I am, and I've been leading this user group for, I'd say, about 7 years now. And then Ken Santarelli is also kind of my co-lead. He runs one of the .NET stream, and I run the Xamarin stream, which is now merged into a mixture of technologies. Dan Wilson is also assistant co-organizer. You see him always running around, setting things up, tearing things down, handing out tickets, keeping things in order. And Arlen Noguera. And so that's the committee. And if you ever have any questions, you have suggestions for meetups that you would like to see us bring, like any topics that you want to see us bring that we haven't brought yet, just message one of us and we'll make it happen. Like I'm pretty sure Brandon messaged Dan. I don't know why Dan, because like we both work at Microsoft. You could have just emailed me directly. Somehow he messaged Dan. And then this is how we made it happen. So thank you, Brandon, for reaching out, because I was super excited knowing that you flew in from San Francisco to kind of do the tour of the Southwestern Ontario region. For tonight's session, use our usual hashtag for our user group, CTTDNAG, and then also because our topics are related to Azure, Xamarin, IoT, and then blockchain, so if you want to use any of those hashtags as well, that would be awesome. And at the end of the session, please rate the meetup. Let us know how it is, what you thought of it. Leave comments, what you liked, and any recommendations for what we can improve, because that would be awesome. Because we're always using that as an opportunity to make these sessions better for you guys. And like, your feedback matters to me 100%, and we always make it happen. But don't ask for anything crazy, because if you start asking for celebrity speakers, not happening. Okay, this is as celebrity as it gets. Can't afford anything beyond that.
He's almost a celebrity. Kid you not.
So upcoming events. Prairie DevCon is in Winnipeg this year, and it's amazingly not happening in the winter, which is awesome. It's next week. I'll be there. It's June 5th and 6th, and I think registration is still open. So if you want to travel out there and go to a really cool Canadian conference that's not specifically focused on one technology, they are very technology agnostic. There's going to be a wide range of topics there. Definitely worth checking it out, and it's very reasonable. And then our last session of the season is coming up June 13th, and it's our lightning round session. And I already have the agenda posted. We have some awesome speakers, and we're starting at an earlier time, so we have doors opening at 5 o'clock. The first speaker will be up, I think, at 5:30ish, and then we're just going to end at 7:30. So it'll be an early start, early wrap up. If you can't make it right at the start, don't worry. Just join anytime you can. That would be great. I think we have like 5 speakers lined up, and Dan's one of them. Dan's going to talk about stuff, so yeah, it'll be his first time. So, wow. And same with Josh. Josh is also going to be talking, and Josh is new to the KW area, so make friends.
Presentation. I was going to say something about IoT and its applicability. Another use case, yeah. So last week I was in Disneyland. Actually, no, Disney World. And who has been there recently? Okay. So they have a Disney World app now. And this app pretty much gives you everything you need to know in the park. It gives you all of the wait times for every single ride that you want to get on. So now I know, okay, if I'm in this part of the park, if I need to go here, there's a 45-minute wait time. Like, it's really, really useful in planning your entire day, right? So all of this is through IoT, right? It's all through the wait times, the queues that are obviously connected. And you can actually, so they have this idea of a fast pass here. So, you know, it essentially will allow you to bypass the lines 3 times. If you are to book the ride that you want to get on, in advance, so I can do that through the app. If I want to view all of the pictures that they took, so that's my father and mother-in-law with Princess Ariel, who looks exactly like Princess Ariel. That was the craziest thing ever. But yeah, like everything you need to do is through the app, right? And I found that extremely cool in terms of the wait times. Super useful. 105 minutes? Jesus Christ.
Can IoT remove the wait times?
I don't know. But the other thing it also showed was how this right here, Space Mountain, was down. So I know, okay, I'm not going to waste all my time walking all the way to the other side of the park if the ride is down, right? So that just actually came out to my mind. But anyhow, okay. So my name is Madi. I am the technical blockchain lead for Canada. I used to work actually on Brandon's team in San Francisco, so I used to live in San Francisco for 3 years, and then I moved back home in November, actually, which is kind of weird, like right in time for winter. So I moved back on hammered, so I'm like, okay, I got to remember what it was like being in Canada. So my role involves helping our customers in Canada on blockchain. We have quite a bit of a technology stack in blockchain available, and I'm going to go over one of the products that we have is called actually Blockchain Workbench, which just came out in a public preview mode at Build. So that was about 3 weeks ago. And I'm going to show you guys how to get up and started with a blockchain app. So before I get started, who's heard of blockchain? Obviously, probably everybody. Okay. Who has heard of blockchain apart from the cryptocurrency sense? Cool. Okay. And its applicability in enterprises and whatnot, right? Awesome. So the disclaimer is that we're not going to give you the technology to set up a mining rig in Azure. That's not the case here. Azure blockchain. If that's what you're thinking. I mean, you could if you wanted to mine, but it's going to cost you a load of money, so you probably won't do that. No. But so what we're talking about is private blockchain networks between, like example, companies or say the big banks or something, right? Who want to take out the guy in the middle, and they want to create a single source of truth of data amongst themselves, on which they can agree upon, they can audit, of course, and you have a trail of liability, kind of, right? So, like, who did what, when they did it, right? When the transaction was there, and etc. So I'm just going to go over probably going to skip these slides in terms of what a blockchain network is and what it involves. Pretty much it's just a ledger system that is distributed amongst a bunch of nodes, and essentially all sorts of transactions that are recorded on this ledger get completely replicated on all the members of the consortium who operate the nodes. This blockchain is a secure, shared, distributed ledger. Here's an example of data that is stored in a ledger. Say Alex were to send Katie a payment and all these other ones. Every node on the network has the exact same ledger, and that's how you know who's accountable and what the history of those transactions were or was. So where is blockchain valuable? It's mostly, if you can answer these questions, then you know if blockchain is applicable in your enterprise or in your specific use case. And it's going to be, is this a business process that crosses traditional trust boundaries? Do multiple parties have to share their data and they don't want to hold one specific party liable? Is there a requirement for any kind of verification, and can any of the intermediaries be removed? And if the answer is yes to all of these, then that makes sense for you to explore a blockchain type of application. It's kind of complicated. So just a question, has anybody actually experimented with blockchain? Have you tried to build a smart contract or a smart application on Ethereum or anything, or no? Has no one done that? Okay. Do you guys know what the concept of a smart contract is? Okay, so for those who don't know, the idea is that you have this contract that is smart. It contains code. The idea is that, you know, if this account is if the code is to be triggered, then that code will always run the exact same way. It can never be changed, and that code will do something. So there are examples of blockchain apps out there in the wild. In the real world, there's an example with AXA, who is an insurance provider based out of France. They have a blockchain application that exists right now for flight insurance. So what happens is that every single e-ticket has a unique number. You supply them with your ticket number and your name, and you also give them a down payment. So I'm not sure what the currency is, but anyhow, the idea is that if your flight were to get delayed by 2 hours or more, you're going to get a guaranteed payout. So there's no need for me to go through the broker or the guy who is in charge of claims and all that crap, and you just have to file a claim to get the refund that I'm entitled to. And the reason for that is because if all of the information is out there, it is public, right? You know, you can just go onto websites like flightstats.net or something, right? And you see all of the history of all of the flights. If it were to get delayed, then you just get an automatic payment. So there's a smart contract there that is responsible for saying that, okay, if this flight is delayed, deposit X amount of money into Brandon's account. So it's pretty cool, and it's out there, and it is live. Not always into Brandon's account. That's how you end up with how you end up with like a hack or something, which is there as well, right? You know, if someone were to get access to your contract code and could change what the code in the contract is, then they could absolutely steal a bunch of money, which has definitely happened in the past, as you've seen. But that's on a public blockchain network, not on the private blockchain network that we're talking about today.
So when you talk about crossing trust boundaries on a private blockchain, that means the parties do not trust each other.
They do not, but they kind of do. So in the private case, you have this like semi-trust type of boundary. So say I am a pharmaceutical company, which is an example I'm going to show, and I need to ship the drugs from my plant to a pharmacist. So along the way, there are different sorts of counterparties, right, that will handle the drug, right? So if anything were to go wrong along that chain of custody, like I know, like example, like I know who what is it, UPS is, right? You know, like I know who these specific companies are, but I don't trust them in the sense that, okay, can I trust that, you know, my product was in your hands when something happened to it or not. So the idea is that there is a semi-layer of trust that is there, but if I want to transport a good, like as an example, IoT thing that I was going to talk about, so probably the drugs, you know, was a bad idea, but say I am transporting ice cream and it has to stay within a specific temperature. So if I have an IoT device on that crate, then it can detect the change in the temperature, and when the temperature goes out of a specific range and I know that my ice cream is going to melt, then I can put a timestamp on the blockchain, a transaction that says, hey, at this time, this happened, and things were outside of the normal range of compliance. Okay, who had custody of my stuff at that point? It was UPS or whatever. So you know that, okay, it was their fault, it was under their custody at that specific time while I was actually transporting this good from A to B to C to D. So,
And actually the trust is given by proof of work that the mining operation is doing, yeah?
So I'm glad that you brought that up. So proof of work is a consensus algorithm for those who don't know. Actually, I could also post a link to how blockchain actually works. But so proof of work is a type of consensus algorithm where the way in which you prove these transactions or the blockchain the blocks is by doing a complex sort of computational problem and solving it, and then you have to like do work in order to prove that this block of transactions actually happened. In the private scenario, you don't need to use proof of work anymore because it's not a public network where there is no trust whatsoever. You do have this semi-trust, so it can be through proof of authority or proof of stake. So you no longer need to spend a bunch of computing power on doing this because, you know, if you have a limited number of nodes, right, then you don't need to have proof of work because the currency that's involved here has no value. So you don't care who actually, you know, owns the currency or anything, right? The idea is that we can distribute this this ledger amongst all people in the consortium, right? But I don't need to actually spend the money or the power to actually compute the hash to assemble the block. So in private blockchain scenarios, you don't use proof of work. Yeah, it's proof of authority or proof of stake, or there's like a bunch of other ones too that I have no idea of. There's just they're coming up with new ones all the time. If you guys want to know more about those consensus algorithms, I will post a link in Brandon's gist, or actually he will post a link after I give it to him.
So then if I can still put a question. So how, because proof of work means you do some CPU computation.
Yes.
Yeah, you put some CPU computation before writing the information on the blockchain, yeah?
Yeah.
So that after 10 blocks, for example, if someone wants to change, he has to do all that computation for each block.
Exactly.
So it's hard, that's sure security.
Proof
yeah?
of work also allows it to be randomized in the sense that, you know, you have the ability, if you have enough computing power, to calculate the hash, right? Because you have to give a reward to people who are actually spending the computing power to get something back, which would be the currency in this case, which actually be the cryptocurrency, which would be, you know, Ethereum or Bitcoin or whatever. But in this case, because like I'm still the currency is still going to be Ether, right? Although it's not going to be the public version of Ether, so there isn't any value associated with me computing that, right? The value is in the fact that I'm sharing the ledger with everybody. So I don't need to do proof of work anymore to come up with the block, right? Like it can be assigned in kind of like a random type of a thing where you know every party will have the opportunity to transact to validate the transaction. So you don't need to have proof of work if it's in a private blockchain scenario. That's the thing.
I'll read more into it because it's the security of blockchain is initially it's assured by proof of work.
Well, it's assured in the fact that you have the blocks that are attached. So we can chat about this later too.
Okay.
I'll bring it up. Are there any other questions at this point? Okay, we'll just continue with it. All right. So we at Microsoft, we have worked on a bunch of different POCs with our customers across a lot of different industries, from manufacturing to insurance and banking and government and health and etc. One of which was actually the pharmaceutical case, which was with 3M, where they wanted to actually verify the authenticity of the product that was sent from the factory to the end consumer, to the pharmacist. And actually the motivation behind this is there was like I think $300 or $30 billion worth of fake drugs that are sold on the black market. So that is kind of what they're trying to address here. In fact, actually, sometimes the forklift operator will intentionally ram into the box of drugs just to spill it out and say, okay, this is damaged goods now, and then they will take it. It ends up on the black market. So stuff like that does definitely happen. So 3M actually, they came out with a label as a service where they have a label that if it is ripped, then you can't scan the QR code and then put that transaction on the blockchain to state that. So it's like a two-factor type of thing. So you have a label, and you also have the blockchain there that actually shows the record of the chain of custody. Now, the point I'm trying to make about all this, we'll just skip actually the Nestle one, which is provenance tracking. No, not everyone is using blockchain right now because it's designed for cryptocurrency, not the enterprise. And there's a bunch of challenges involved in blockchain. One of the major things is that all the smart contract code that I talked about, that all exists in like one piece of code. So your business logic, your actual the ledger, like all of the code that relates to how your application works is pretty much in this one piece. So you can't really separate the model from the view and the controller as well as you can with a traditional 3-tiered architecture. And integration is very, very hard. I tried to build a blockchain app. I did once, and it's very confusing because it's a totally different way of thinking of how you want to get all of these things working together. So you have this idea of, okay, there's a blockchain network first of all, and then I have to communicate with these individual servers, which are the nodes, to upload my smart contract code, and then that gets run, and then you have the problem of authentication. So how do I know a user is actually a user, right? Who are they? There's just a bunch of, and it's all open source and under active, heavy development, so it's changing a lot, and it's quite confusing. Actually, the docs change every 2 weeks or something, so it's hard. And when we've worked with some of our customers, it ends up actually costing them upwards of 300 grand and 18 weeks to stand up a working proof of concept on blockchain, because there's just so much involved. And half of that time, actually more than half, is spent on all of the scaffolding that goes around the blockchain, because the blockchain is just the database, if you think about it, right? Apart from that, I'm going to need an API layer, I'm going to need an application, I'm going to need a UI, I'm going to need a mobile app, I'm going to need authentication. There's just all of these other sorts of bits and pieces that come into standing up a working blockchain application that take up the bulk of your time. And then you have to make it all work together. So it's quite hard, and it's quite confusing. So what we have at Microsoft is actually blockchain on your terms, integrated with your business for the enterprise. So at the end of the day, there are so many different types of blockchains available. You can choose any type you want. You can spin them up all in Azure, and you can have a blockchain consortium that sits within Azure that you can manage. Now, on top of that, though, we have blockchain workbench, which is the meat of the conversation, which I want to show you guys today. The idea of workbench is we want you to reduce the amount of cost and time, get off the island, and move towards production. So essentially, it is a template in Azure that you click on. You provide it with a few parameters. It spins up a working blockchain network, complete with a blockchain application in a box, complete with authentication and a Xamarin mobile app, which I built, and I'm extremely proud of it. And the idea here is that all you have to do is upload your smart contract code. So all you have to focus on is, okay, what is the idea of a smart contract? How do I build out a smart contract? Provide this other JSON file for the metadata around that smart contract. You upload these two, and you have a working application, right, with a website, an API layer, .NET SDK, Java SDK, all sorts of other SDKs. Integration actually with IoT as well through IoT Hub. So that the refrigeration sample where you have to transport ice cream, we actually have that as a demo. And we have a GitHub page that has a whole bunch of demos available there too. So if you want to play around and actually learn, how do I build a blockchain app, you can definitely do that with Blockchain Workbench. So the idea is to reduce the amount of time that it takes to stand up something that actually works. So it's pretty cool. And essentially, this is what's involved. You have the smart contract logic, which is in the form of a smart contract, which has its own language. It's called Solidity. And then you have the metadata around that smart contract. You upload them, and you have a blockchain app. And I'm going to show that to you guys right now. Cool. Oh yeah, and also this part too. The cool thing is that you can build a whole bunch of other apps on top. So all of the other things that work in Azure will also work with this. So if you want to pull information out of SAP or Salesforce or Outlook or whatever, if you want to build an IoT app, right, you can use all of the services you have available to you in Azure right now. And there is a video too that I can also show, which is pretty cool. It actually involves the sample of the smart refrigeration. So, the idea is I do have to transport ice cream, and then he actually holds up an IoT sensor and he heats it up with a hairdryer, and then that causes the contract to go out of compliance because it is published onto the blockchain itself, and then he gets a push notification and a call through Twilio that says your good that is being transported by Shady Shipping has gone out of compliance. Press 2 to acknowledge this, or 3 or whatever. So the idea is that everything is so well connected that you don't need to have the guy in the middle anymore. So it's pretty cool. And this is all the stuff you get in Workbench, as I mentioned. You have the REST-based APIs, the administration experience and whatnot. To give you a flavor of what's the architecture is like, it's like this. So there's a ton of stuff that's involved. Actually, this is even a smaller one that is the real one. But anyhow, there is, you have the virtual machines and the databases and the storage and everything here. So let's go to Workbench now, show you what that looks like. In the show, we have, it's called Azure Blockchain Workbench Documentation. Again, this is the link I'm going to give to Brandon to put into his gist later. Oh, I think I'll just do it from here. Okay, yeah, so that's the documentation. If you want to stand it up, you come into the Azure portal, you create a resource, you search for Workbench, not WordPress, Workbench, and that's the one, Azure Blockchain Workbench. You click on Create, and you supply it with these things here. Most of them are just passwords and the VM username and whatnot, but then because you have to stand up an Active Directory as well, it just needs 2 parameters for this portion, which is included in the documentation, not this one, in the documentation on how to get started. So you do need to do some pre-work, but it isn't that much, to be honest. And what it spins up for you is, just to get an idea of all the stuff that goes into just like a bare bones kind of blockchain app. Let's see. Right, so I don't know if you guys can see this here, but these are all the resources that are spun up. So there's quite a bit that's spun up for you in this ARM template. There's a lot of stuff that comes up. But you'll see that I have this thing that says Madi QESK. And if I go to Madi QESK.azurewebsites.net, not that one, this one, this is what Workbench looks like. So what Workbench gives you in the first case is you have this idea of applications. So an application contains one or more smart contracts that can or cannot work with each other. Right now in the UI, in the preview mode that it is right now, every application has just one smart contract. You can upload a new application. You click on the plus button, you go to browse, and here actually is the sample that I have of the smart contract. So here's a smart contract. It's called a digital locker. All it does is it just stores the value, stores this value inside a locker, and if you have the password or whatever, like it unlocks. But this is what smart contract code looks like. It looks very similar to how JavaScript is. Ooh, what did I just do? What the hell just happened? Brandon, do you have any idea what happened? This is VS Code. I don't know.
You wrote it. Oh, I see. You brought up that toolbar at the bottom.
Yeah.
How the hell?
Yeah, just lower that.
Go down just a little bit. And
Yeah.
Grab it.
Yeah, I'm trying to grab it, but what?
Double click.
No, but the toolbar went away too. Huh, okay, whatever. Let's just close it up and bring it.
Okay.
No, this is the other one. I don't want this one. Here we go. Okay, so smart contract code looks a lot like JavaScript, but essentially you have to just inherit from a workbench base contract. It goes through all of this inside the documentation, but you have the smart contract and you have the metadata, which is just a JSON file that describes it. So what this describes is, as an example, I have the different types of roles inside my application. I have different types of workflows, and the workflow in this case is a smart contract. So, this smart contract is for a digital locker. That is one workflow within Workbench, and then every instance of this contract is just called a contract. I can show it to you guys as well. But all the other stuff you describe inside the JSON file, the stuff like the properties, the different types of the functions that are available, as well as the constructor and the different states of your smart contracts. So if you think about me wanting to transport a good through a shipping company, right? The states can be in transit, it can be completed, it can be out of compliance, it can be delivered, etc. And the different roles that are allowed to access this specific state. And you'll see how that comes up in the UI. So after I upload this, it comes up like this. So I have the asset transfer contract here. You can manage who has roles within this specific smart contract. Within this application. So I can add a member here. We have this guy whose name is buyer John. He is within my Active Directory. So I can add buyer John as a buyer, of course. I add him, he comes up. I can add owner Alice. Owner Alice is going to come up as an owner. Okay, great. Right. Then the idea is that these are the three members who are here. And here's one smart contract of a car. It's an Audi S6. I love Audis. But anyhow, if I want to sell my car, right, I will have to post this car. Sorry if I'm standing in the way. But just kneel down a bit here in the corner. Okay. If I need to sell my car, I have to post the car up. Then you have different types of people who can take actions on this car. So either they can put an offer, they can reject the offer. After the seller, has agreed to the price, I accept the offer, then I can assign it to an appraiser or an inspector, right? And then once all the parties have gone through, then the contract is in its final completed state, and maybe there could be another smart contract that can, move the money from X's bank account into Y's bank account, right? So that's the whole idea. So here you can see that I can take action on this car here. The price is $100,000, which is a lot for an S6, to be honest. I can modify this, take the action. So because I'm logged in as myself, I can also change the description because I'm the owner persona here. So it's still an Audi S6, but if it's used, make it 785 maybe. I don't know. Depends if it has a V10 or not. That was the older one. But anyhow, take that action. The action will be posted onto the blockchain, and you can see the history of these transactions one by one. So the very first transaction that was posted was the creation one, where I gave it a price of 10K accidentally, which would have been a bargain. Date and time, the block, from which address to which, and then actually this is just the hash of the transaction. But anyhow, the idea is that now my action was posted successfully. So that's the idea of App Builder. Workbench. It used to be called App Builder. I accidentally said that. Don't call it App Builder. It's Workbench. Workbench only. That's the idea of Workbench. Is you have this whole thing, and then there's a whole SDK that comes with this. So that's how we built actually the mobile app. In order to get access to the mobile app, there's a link. There's a public link. It's on App Center. I'll put that in also. I'll give that to Brandon too. Once you put in that link in Safari, if you're on iOS, or in Chrome, of course, if you're on Android, you can click install. It will go ahead and install the app. This is an enterprise certificate, so you have to go into your settings and enable the developer, which is Xamarin in this case. Let me see where that goes. Developer, device management, I don't remember. But anyhow, yeah, there you go. So you go into here and then you will authorize Workbench. So when it starts up, it's going to ask you for a QR code. The reason for that is that what Workbench does, give it a second. After you install if you install anything from App Center, it bumps you up into here. Have you guys heard of App Center, by the way? Okay, for App Center, okay, great. So anyhow, you scan a QR code. So in the GA version of Workbench, there's going to be an admin panel, and then if you click on that, you can scan a QR code. So the code for the mobile app is going to go up onto GitHub soon, in about a week or so. That's also where all of the other examples are in GitHub too, which Brandon, of course, sorry. But you'll notice that you have to create a QR code, of course, because it doesn't exist in the app. This will take me to my Active Directory where I have to log in. So I'm going to log in as buyer John. It's just blockchain. So for me, of course, it's blockchainapps.onmicrosoft.com. Obviously, you're going to have to create your own. Next. And the password is blockchain. All right. Comes up here. There you go. So I'm logged in as buyer John. I have an asset transfer workflow available to me. So you can do everything you can do from the website except for uploading your smart contract, because then you'd have to have that code on mobile, which doesn't make sense. But so just if you take a look at this, so let me put these two side by side. So here's that Audi S6 that I had under asset transfer. I can go inside here. I am buyer John, so I see the activity in the contract, all the different states. I can contact the owner, which is myself. The actions I take, so this whole thing is completely dynamic. So all you need to do is just scan that QR code and it just works. So I'm going to make an offer. I'm going to make owner Alice the inspector, the appraiser. I'll make it myself. I'll give an offer price of 50K. I'm going to lowball myself. I press submit. So it's going to submit it onto the chain. You'll see it came up there, right? So buyer John called that. It's taking the action and it's going to get posted. And you'll notice that the status will change to offer placed, right? So that's the idea of Workbench. You have everything in your pocket too, it's pretty cool. And then obviously now the action I can take on this is not the same anymore, right? Because I've already placed an offer. So I can either modify the offer or rescind my offer, right? Or cancel. I can do that too. Now, if I was logged in as an owner, So let's come in here and change buyer John into an owner. Where is it? There he is. Let's make him an owner. Did you see the plus button pop up there? Cool. So now I can actually make my own contract. So this will be an Audi A6 maybe. It's going to be cheaper than the S6, so let's say 60 grand. And we'll proceed to make that contract. And contract 2 is now being created right there. And it updates in real time and whatnot. So this is going to be up on GitHub within next week. You can either clone the code and compile it and change it actually, however you want. Or you can just download the app, which will always be the latest stable version of the application. Is going to be off of App Center. But yeah, that's the idea. Oh, and if you want to remove, did that come in? Yeah, it came in. If you want to remove, you just do like a long press, then you can add in a new environment. But yeah, that's the idea of blockchain workbench. So if you guys found it interesting, if you want to play around with it, by all means, yeah.
Can I do this on local machine? You mentioned something about Active Directory setup.
So this is an app that's in the cloud, right? So you wouldn't be able to deploy this on your local machine. The whole idea of this is that I have a web app and it scales up and down and everything in terms of traffic and whatnot. So I don't think you can deploy this workbench locally, no. Now if you wanted to build, a blockchain app locally, you definitely can without using workbench that gives you all the scaffolding, but as I mentioned, there's a lot of steps involved. It's quite confusing.
But I mean just to play with it,
Just to play with this?
No, with the workbench. I cannot play with the workbench locally. I mean to deploy something locally connected to the cloud.
So when you're talking about local, was that someone here? Josh? No? Who's Josh? Alright, whatever. You can't deploy this, because this app is being hosted inside Azure. So,
Yeah.
so you wouldn't be able to deploy it locally. That's what the whole ARM template is, right? Like it's going to spin up all those things in Azure, including the web app and all that stuff. So if you wanted to play with it, you could use the $200 credit that Brandon's link gives you, spin this up. It can get a bit expensive though, so just be careful.
How expensive? Over 200 hours?
It can, if you're doing a lot of transactions. Of course, right, but that's like on a monthly basis. So if you're just going to be playing with it, I would spin it up and then spin it down, when you're done with it. And I think we may have like a few, like public ones available. I'm not sure. But if you want to get in contact with me, I'm more than happy to help you guys out with my engineering group. All right. Next question. Yes.
What if I had on-prem Azure? Could I do it?
On-prem Azure?
Yeah.
You mean like Azure Stack or something?
Yeah, that idea.
I don't know if they've put this on Azure Stack yet, but I think they are in the plans to do that because a lot of people want to have the ability to have their own nodes on-prem and not be in the cloud. So that's there,
When you split it up in Azure, obviously created a bunch of resources, great, but then we moved over to the workbench. And we never went back.
Yep.
Which is, actually, I'm totally cool with that. Because my question is, do you ever have to do anything in the Azure portal after this is done?
Nope.
This seems like a lot in the portal.
You don't have
The
to.
workbench seems like
No,
something I
you
can do.
don't. You just have to take the name that's over here and click on whatever the URL is. That's it. Now, if you wanted to add your own IoT hub, yes, you'd have to do stuff in Azure. If you wanted to play around with Event Grid or Event Hub or any of that stuff, yes. But the samples are there in GitHub. Yes.
Integration-wise, between blockchain and like any old plain old C# app, what was the integration work like there? Was it difficult to
Could
get
you
in?
repeat that? The
So
integration?
like, if you wanted to get into the blockchain from C# and you wanted to extract data or you wanted to have a history
Yeah,
or any of that
Yep.
jazz, how
I'll tell you.
difficult is the
Sure.
interaction?
All right.
Because this is all super nascent stuff, right? Like it's getting there, but those kind of scenarios are super interesting because if you're
Like actually get data from the blockchain is what you're saying, right? Through any language of choice, right?
yeah, that's right.
Yeah.
C#, whatever.
Exactly. So if you're working with Ethereum, then you're going to be working with Geth, which is the way in which you talk to an Ethereum node.
Yeah, it's the daemon for
Exactly, yeah. Then there's Web3, which is the JavaScript library that wraps all the if this is like a node, right, on the blockchain network, any call I make to this node is through RPC, which is remote procedure call. So it's really sort of, as Brandon likes to say, janky. Super janky, right? I'll never forget that, Brandon. But you will, so those calls look really weird, and you can code them out by hand, but there's a lot involved. So then there's a wrapper around that that's called Web3, which is the JavaScript library that the Ethereum Foundation has come out with. And it looks something like this. So here I am in a node. Let me zoom in this time without messing up. Here I am in a Node.js app, a Node app where I have the backend. So you can think of it like, I have the Ethereum nodes, so 1, 2, 3, 4, 5. These will contain the information on the accounts and the smart contracts and stuff. I talk to them through Web3, which would be in like a Node app or something, which then has all of those calls wrapped around like an API call, which then my front-end client knows. Like, the idea is that the mobile app shouldn't know that I'm talking to a blockchain network, right? Because it has no business knowing that, there's a blockchain back there. That's all for the backend. So the backend would need to use Web3. And it looks something like this. Like when I want to deploy a new contract, let's see, where was it? So here's like an API endpoint, which is like /sign up, right? So you have this idea of a contract, and you have to compile the contract into some sort of JSON, and that compiled contract is compiled through the Ethereum compiler. So it compiles it down, it gives you like this ABI, which is the application binary interface. Well, you can see this call to Web3 here, and you're like, okay, there's a specific port on this node that's open, and it is listening to my Web3 calls. Then I invoke stuff through that call. So in this case, it is web3.eth.contract with the information of the contract ABI, which is essentially the I don't know if it's hashed or anything. I'm not quite sure because I'm not an expert on this, and quite frankly, no one is an expert because it's just really janky. But you deploy this, so the ABI is like, okay, if I've deployed a contract so this contract has to exist on my Ethereum network if I'm going to make a new copy of it.
Is it
like a new instance of it.
Is it like a SOAP endpoint? Essentially, you create a contract. It's the equivalent of a SOAP endpoint.
Kind of. Like this contract exists, but I have to tell my node to go and fetch what the definition of that contract is, and then to deploy a new contract instance of it with the parameters in the constructor and whatnot. So,
do you get data through a contract?
Yes, you can invoke a bunch of different types of methods on the contracts. So you can put in methods on your contracts, so like a getter or like a setter or that
So
stuff.
I guess my question kind of aiming for is more like, I currently want to have an audit trail of the ice cream truck scenario, and I know here's the ID of that
Transaction.
Of ice cream. I am going to create a contract that knows about that skids on the blockchain. I give that ID to once it's deployed, and it will give me.
And then pull. Yes, you can pull the state of that contract.
And I would have to write that contract in order to get that data stream.
No, so that contract that contains just that smart contract, right? So the contract that contains all the logic for, transitioning the ice cream or whatever. So each time I am sending a new box of ice cream, right, there's like a new contract instance for that ice cream, and this thing moves along the chain, right? Like it moves and its states get updated. So you have to know the address of this contract so you can read the properties of that contract at any given time,
So it's a
including
contract
its state.
instance?
It's a contract instance, yes.
Okay.
Which is what I meant by you have the one contract, but then, so you have to have like the contract itself deployed on the network, but then through this ABI, which is the binary interface, you tell the network, okay, go fetch this contract, and this is what my new contract is going to be based on, right? You know, there's a new contract instance which is based on this master contract or whatever, right? Right. But then after you have that, you deploy it through my contract dot deploy, and then when you deploy, you have to send it from an account that has an amount of gas, which is ether and all that stuff. So there's this whole way in which the Ethereum virtual machine works, which is like a whole other sort of thing which you can read about. Feel free to do that. I'm not going to explain it. And then, you know, once it's created, then I outputted the address of that contract. Now, whenever I want to update that contract, I need that address. So I have to have that stored. Where would I store that? In a SQL database. So that's the whole idea, is that there's all this stuff that goes along with any Ethereum or any blockchain application, because all the blockchains is just the ledger, right? I'm still going to need to get stuff into it and stuff out of it. I need to store that stuff somewhere else, which can probably be in SQL, and I have to read that and update. Like, you know, there's a bunch of stuff that's involved.
So why would you use blockchain in the enterprise then? Like, what is the real advantage if you're really pulling data in and out of the database, keep a log of all the transactions that happen?
Well, you have a
What's the
log,
strength?
so no one can lie about anything anymore, because the entire trail of everything that happened is on the blockchain. So this ice cream that started in this new state from Briars or whatever, right? That batch of ice cream was made at that time, right? As it moved from the factory into Loblaws, at some point in time, it melted, right? So, or if there were to be, like a product recall or something, right?
Right.
And you wanted to know, okay, at which stage along the actual manufacturing cycle did I get my infected, cream for ice cream, right? Like, it could have not been
So
from me.
because
So you,
the trust between corporations that are
exactly,
dealing in that chain?
you don't have that trust on a normal basis, but all that trust is then hidden within this chain. So that's
And each player has a copy of the
and
chain.
each player has a copy of that chain, right? Everybody has a copy of it.
Yeah, well, it's about the track.
Yeah. So you're
you're passing contracts instead of making a monolithic system that tracks the whole thing.
yeah, and then not one person is liable at this point. So in terms of auditing and compliance and all that,
Sure.
you can say, okay, here's all the data, go and do it, and you want to go and audit my data. I don't have to go to XYZ, Corp and ask them for their entire log of audits and everything. Like, all that's just there. It's on the chain. Feel free to do whatever the heck you want.
And you can easily do audit it. Yeah, anybody
Yeah,
that has the chain can do an audit on the information. Yeah.
Transaction log driven by Git. Right.
Transaction log driven by Git.
Yeah, well.
Yeah, right? I joke about that too, how you can always see my bad code on GitHub no matter what. You probably have some blockchain stuff.
Without having to open up doors, get VPNs, extra this.
Yeah,
It's
you have the
just,
entire
this
log.
is the way you do it.
It's all there.
This is the distribution mechanism for sharing out information.
Cool. Awesome. Well, I hope you guys enjoyed. Oh, the video. I'll send that to Brandon, but
Mark's example, but now we've got all the systems in place, the smart contracts are active, and we see all of this in action.
this is
You bet.
15
So we have
minute
our Raspberry Pi here. We also have a Thunderboard, which is collecting our temperature information. And we'll be reporting that out to our
This
IoT.
guy's actually the
So we
director
need
of
to actually
blockchain
get this
innovation.
working and test it out.
Right.
So let's shift over here. You can see that I have both the web app that you
There's
saw
my
earlier,
app.
as well as the Xamarin application for the samples the Xamarin folks have put together for us running on an Android device. On the right-hand side, I'm logged in as a company called Shady Shippers, and on the left-hand side, I'm logged in as me. And so you can see that there's this contract that's been created, but it isn't reflected over here. And the reason why is because I haven't associated Shady Shippers with that. So what I'm going to do is go ahead and transfer responsibility, one of the actions that we saw in the smart contract earlier. And now I'm going to go ahead and assign that to this company called Shady Shipping.
Sample contracts are on
Click submit.
GitHub too.
Now
So
these
there's
are
like
both
a
in the
ton of sample
blockchain.
contracts.
That is just submitting a transaction to the blockchain, but because both parties are connected to that, we'll see in just a moment that, as we can just see just now, it's now shown in transit on the right-hand side, in transit over here. So now we've got this one blockchain, a common source of truth, running on the blockchain across both the organizations and in near real time.
Very cool. So another benefit
So
of
he
blockchain.
was logged in as Shady Shippers on one side and logged in as someone else on the other side. So that's what he meant by that.
And they're both in sync. And everything's ready to go. I want to simulate the actual the truck losing power, or the refrigeration unit losing power. And here we actually have
Sorry if I went over.
our temperature sensor, our IoT device. It's actually sending Bluetooth signals out to our Raspberry Pi. And I've got the perfect device here to raise its temperature. So we're going to go ahead and hit that with some heat. There we go, that should do it. I'll put this down and let's see if that... Wow, that was quick.
That was pretty darn quick. All right, so let's go ahead and answer that call. The speaker.
Potential food safety issue that needs your attention. You are receiving this message to alert you to an issue with a shipment being handled by Shady Shippers.
Okay, so it sounds like they've detected something as a foul here in terms of our
To
shipment.
have the shipper return the product, please press 1. To have the shipper destroy the product, please press 2. To alert, we have recorded your response to and will communicate it to the shipper. Thank you, and have a nice day.
Now something cool on this is that, so I asked, okay, so what if I have a bunch of IoT devices who are sending rogue information up? Is it just like secure, crap that comes in and goes out, so, it's garbage in and garbage out, but it's transferred in a secure fashion? Well, the idea here is that you can override that too. So you have code inside your contract that says, okay, if this were to happen and it comes out of compliance, call this guy and give him the option to override. If he doesn't override and he accepts that this happened, then yes, for sure this did happen. So that's kind of how you have that whole chain of stuff. But yeah, I'll put this link as well in Brand's just. That's all I had. Thank you.
Thank you.